Let us introduce you to this topic. The corpuscular model of light derived Snell's law and explained the laws of reflection and diffraction of light at an interface. It predicted that if the ray of light on refraction bends towards the normal, then the speed of light would be greater in the second medium. This corpuscular model of light was further developed by Isaac Newton. In 1678, the Dutch physicist Christian Huygens put forward the wave theory of light. The wave model could satisfactorily explain the phenomena of reflection and refraction. However, it predicted that on refraction, if the wave bends towards the normal, then the speed of light would be less in the second medium, contradicting the corpuscular model of light. It was much later confirmed by experiments that the speed of light in water is less than the speed in air, confirming the prediction of the wave model. Foucault carried out this experiment in 1850s. The wave theory was not readily accepted primarily because of Newton's authority and also because light could travel through vacuum, and it was felt that a wave would always require a medium to propagate from one point to the other. However, Thomas Young performed his famous interference experiment in 1801 and established that light is a wave phenomenon. The wavelength of visible light, like yellow light, was found about 0.5 micrometer. Because of the smallness of the wavelength of visible light, light can be assumed to approximately travel in straight lines. The branch of optics in which one completely neglects the finiteness of wavelength is called geometrical optics, and a ray is defined as the path of energy propagation in the limit of wavelength tending to zero. In the upcoming decades, experiments were carried out involving the interference and diffraction of light waves. These experiments could only be satisfactorily explained by assuming a wave model of light. Thus, around the middle of the 19th century, the wave theory seemed to be very well established. The only major difficulty was that since it was thought that a wave required a medium for its propagation, how could light waves propagate through vacuum? This was explained when Maxwell put forward his famous electromagnetic theory of light and had developed a set of equations known as the wave equation. From the wave equation, Maxwell calculated the speed of electromagnetic waves in free space and found it to be approximately equal to the speed of light. From this, he concluded that light must be an electromagnetic wave.